What do you think when you think of the term geometry? Well, you might think of shapes, lines, yeah, and all angles. Well, what would I think when I think of geometry? I think of logic. And proofs. What makes geometry different from all the other subjects in math, like algebra, is that it involves logic and proofs much more than it does than formulas and algorithms. That's what makes geometry very special. Okay? Which is why people really don't like geometry, because it involves thinking and proofs. I've been lucky to have some very good geometry teachers that have taught me that there are two types of learners, type 1 and type 2. Type 1 always follows the formulas and the algorithms and doesn't actually understand what they're doing. They're like, okay, solve this equation, and then they're like, they use the formulas, and then they type, and then they do the formula and the math and all that. But then type 2 is different. What is important about type 2 is intuition. It's how you should do it. Like, they understand why the formula works, how to use it, and how to prove it. That's basically what geometry is. It's the embodiment of type 2 thinking. So we're going to start learning about geometry and try and learn it intuitively. So before we start, we need to understand a concept about what is the difference between a postulate and a theorem. Wait, what are those again? Well, postulates are like the rules of the world. They're the rules of math. They're already been proved. You don't need to prove them. So they're the rules of math. They are already known, and they are the rules. While theorems are what you need to prove. And they're like a question. You have to answer a question with the postulates you know to prove the statement to help you in your geometry. Like, if two triangles are congruent in two sides and the included angle, then the whole triangle must be congruent. This is a postulate. But then, with the other knowledge, you can prove that a hypotenuse and the leg of a right triangle, if you have the hypotenuse and the leg of a right triangle and they're congruent, then the two triangles are congruent. This is a theorem that you need to prove with theorems like that one. So, before we even get into all that stuff, we need to first get into the basic idea of what we're getting into. The undefined terms of geometry. They're undefined. If you're trying to find them, it's very difficult because they're undefined. As in points, lines, and planes. There's the first dimension, the second dimension, and the 0th dimension. So let's start off with the first term, a point. Well, what is a point? A point is a point in space. It's a minuscule dot in the middle of a plane or any area. Has no dimensions. It just conveys a location. So like, this point is over here. Look, it's over there. Look, right there. Oh, it's right here. There's a point over there. Or there's another point. These points can be labeled with just a singular letter, like this one, point B, or this one, point C. You just call them point B or point C. So, yeah, that's one undefined term in geometry. Now, that was in the 0th dimension. Now let's go to the first dimension. Lines. What are lines? Well, lines are infinite points. Infinite points. So if we took several points, a bunch of points, and connected them all, we would get a line. And this line is if we zoom in, like a lot, just zoom in, we would have multiple points. See, there's all these points. So, yeah, a line can go on forever and ever. which is why there's infinite points in it, because it goes on forever and ever. And in order to determine a line, you need 2 points. We'll talk about that a little later. And the way you'd label it is take the 2 points and write this symbol that looks like a line. So this is called line AB. This is a symbol. It looks like a line, which is why they made that the symbol. This is in the first dimension. So now, what happens if we have infinite lines? What will we get? Okay. If we have infinite lines, then we'd get, if we had infinite points in the 0th dimension, we'd get to the first dimension. So if we had infinite stuff from the first dimension, we'd get to the second dimension. And what stuff is in the second dimension? A plane. What's a plane? A plane is an infinite number of lines. This is a plane. Let's imagine this is a plane. It's completely flat, no width. No width to be speaking of. So you can put points on this plane, lines on this plane, and other points and other lines. And the way you can determine a plane is with 3 points. Let's say we have A, B, D. I know I'm being mean, I would call this one D. So this is plane A, B, D. The 3 points we got. So, now let's talk about some postulates. As we discussed, postulates are concepts that you can use to prove theorems. So let's start with one. The first postulate is saying that for every 2 points, let's have point A and point B, there is one line that connects them. Only one, not 2, 1. Because it can go both directions. So there is only a line AB. And line AB and BA are the same because lines can go infinite in both directions. This will be a different case when we're talking about rays, but we're not there yet. So this is the first postulate. And so to every 2 points, there's exactly one line or a segment. Okay, now the next postulate. If we have 2 lines, 2 unique lines, they will intersect at 1 point, and only one. There are different lines. Like let's say we have line A, B, and line C, D. They can only intersect at only 1 point. The only exception is if the lines are the same. And this is not actually an exception, because if the lines are the same, then it's just one line. They cannot intersect if they're the same line, because they're just on top of each other. Okay. Let's move on. So, now we got a plane. What happens if 2 planes intersect? This is going to be kind of gonna hurt, so let me just try to draw a plane. Okay, let's draw some dotted lines that show that. So, when 2 planes intersect, we get one line. Okay, that's kind of cool. When 2 lines intersect, when they're in the first dimension, they intersect at something. They intersect in the 0th dimension. Then if it's 2D, then they intersect. It's a line. So I guess if it continues, and we have 2 3D shapes intersect, it would intersect at a plane. Yeah, dimensionality is pretty cool. And another postulate is that every plane is determined by a set of 3 unique points. And 3. Only 3. Why 3? Because if it was 1 point, then it would only be considered a point. But if it was 2 points, then we could have a line. So, the next logical step is if there's 3 points, there'd be a plane. And also because if there was 2 points to determine a plane, then we'd only have a line determined. So, let's do a recap. So there are 3 main undefined terms in geometry. Points, lines, and planes. Points are just one single dot in space. They convey location. Lines are an infinite amount of points. And planes are an infinite amount of lines. Through every 2 points, there is exactly one line, or segment, and 2 points determine a line. When 2 lines intersect, they intersect at a point. When 2 planes intersect, they intersect at a line. And 3 points can make a unique plane. So, that is the first topic about geometry, undefined terms. Hope you enjoyed it. Hope you learned something. Bye.